Good afternoon, class. We are looking at trigonometric functions, and here's 6.1 graphs of the sine and cosine functions. We are going to cover graphs of sine and cosine functions, graphs of the tangent, cotangent, cosecant, and secant functions. PS short for phase shift, more graphs, phase shift, sinusoidal curve fitting. The objectives are graphing sine functions of the form y equals a sine omega x by transformation. Same thing for y equals a cosine omega x. Determine the amplitude and period of the sinusoidal functions. Graph sinusoidal functions using key points, finding an equation of a sinusoidal graph. So recall trigonometric functions, the unit circle. In the case of a circle, x squared plus y squared equals r squared, centered at 0, 0 with the radius r. If the radius is 0, 0 and x squared plus y squared equals r squared. If the radius is equal to 1, we end up with a unit circle. So x squared plus y squared equals 1. And with x squared plus y squared being 1 and a point having coordinates x comma y, x represents a cosine and y represents a sine, we can figure the rest of them. Sine tangent is y over x or sine over cosine, and the rest of them are reciprocals. If we use a general r, x squared plus y squared equals r squared, then we have to divide y by r, x by r as far as sine is concerned, and the rest of them follow by writing tangent is still y over x, and the rest of them are reciprocal functions. Fundamental identities, starting with x squared plus y squared equals 1, where p has coordinates cosine theta, sine theta. Then a periodic function repeats its value at regular interval. Every sinusoidal function has 2 pi as its period, except tangent, which is having pi as the period. Even and odd properties, every function, every trigonometric function is an odd function, except cosine, which is an even function. That means cosine of minus x is cosine x, and with that goes secant, secant of minus x is secant x. The rest of them are odd functions. Fundamental identities, Pythagorean identities. From here, we can see sine squared plus cosine squared is 1. Tan squared plus 1 is secant squared. 1 plus cotangent squared is cosecant squared. And quotient identities, tangent is sine over cosine, cotangent is cosine over sine, and reciprocal identity is cosecant is 1 over sine, which of course means sine is 1 over cosecant. Secant is 1 over cosine, cotangent is 1 over tangent. Let's go with 6.1, graphs of the sine and cosine functions. The graph of sine functions, let's start with the basic y equals sine x function. So to do so, we pick the x values, then we get the sine and the pair. For example, we know at 0 sine is 0, so we get 0 here and 0, 0 here. Pi over 6, sine is 1/2, so pi over 6 and 1/2. Pi over 4 is square root of 2 over 2. Pi over 3 is square root of 3 over 2. Pi over 2 is 1. 5 pi over 6. It's the same as pi over 6 in the second quadrant. Sine is positive, so it makes it positive 1/2. Pi, 0. 7 pi over 6. The same as pi over 6, but in the third quadrant, sine is negative. So negative 1/2. 3 pi over 2 is negative 1. 11 pi over 6 is the same as pi over 6 in the fourth quadrant is negative, and 2 pi is 0. This is negative, everybody. And this is correct, as you can see. All right. Let's plot the pairs. 0, 0, pi over 6, 1/2, pi over 2, 1, and the rest of them. And it's a complete cycle from 0 to 2 pi, everybody. Complete cycle from 0 to 2 pi. So for y equals sine x, a complete cycle goes from 0 to 2 pi. We notice there are 1, 2, 3, and 4 arcs. Think about this one as one arc from 0 to pi over 2. This is the second arc from pi over 2 to pi. Third arc from pi to 3 pi over 2. And the blue one, the last one, from 3 pi over 2 to 2 pi. So this is one way to look at it. And we can see the graph of sinusoidal functions using key points, using 4 arcs, everybody, using 4 arcs. 1, 2, 3, 4. Okay. And the key points are the intercepts. Look at 0, 0, pi 0, 2 pi 0. Those are the x-intercepts. And by the way, 0, 0 is both x and y intercept. We have pi over 2, 1, the maximum, 3 pi over 2, negative 1, and that will help craft this nice and easy. Of course, we can continue after the one cycle indefinitely on the right and on the left side because it's a sinusoidal function, it's a periodic function. So the sine function y equals sine x is a fundamental trigonometric function with several important properties. It's periodicity. The sine function is periodic with the period of 2 pi. This means that sine of x plus 2 pi sine of x for all x. Amplitude, domain, range. The amplitude of the sine function is 1. This means that the maximum value of sine x is 1. The minimum value is negative 1. Hence, the range for the sine function is from negative 1 to positive 1. Its domain, all real numbers. Symmetry / odd function. The sine function is an odd function. This means sine of minus x is minus sine x. Its graph is symmetric about the origin. So if you pick a point connected to the origin and go the same distance, you find another point on the graph of the function. Key points, x-intercepts. The sine function crosses the x-axis at the integer multiples of pi or x equals n pi, 0, pi, 2 pi, 3 pi, minus pi, you name it, where n is an integer. The function reaches the maximum value at 1 when x is pi over 2 and then plus 2 and pi, it reaches the minimum, the value of negative 1 as x equals 3 pi over 2 plus 2 and pi. So pi over 2, 1, that's the maximum, and it repeats after 2 pi, 3 pi over 2 minus 1, and it repeats if you add a 2 pi to that. And the y-intercept located at this point is 0, 0, or simply 0. Waveform. The graph of a sine function is a smooth, continuous wave that oscillates between its maximum and minimum values, creating a sinusoidal waveform. That's what they call it. Relation to the unit circle, the sine function can be defined as the y-coordinate of a point on the unit circle, x squared plus y squared equals 1. And these properties make the sine function essential in various fields, such as physics, engineering, and signal processing. Now, y equals sine x, period is 2 pi, amplitude is 1. Y equals a sine omega x, period is t equals 2 pi over omega, amplitude is the absolute value of a. See, the number in front of sine is 1, that's why we didn't put the absolute value, and it's positive always. And domain, of course, from negative to positive infinity. Let's look at the cosine function, and we're going to repeat the same thing by picking up some pairs. So 0, cosine is 1, pi over 3 is 1/2, pi over 2 is 0, 2 pi over 3 is the same as pi over 3, which is 1/2, but in the second quadrant is negative. So 2 pi over 3 is negative 1/2. Pi is negative 1. 4 pi over 3. Again, remember the reference arc is pi over 3, so it's the same as pi over 3. But in the third quadrant is negative, so negative 1/2. 3 pi over 2 is 0. 5 pi over 3 is the same as pi over 3 again. But it's in the fourth quadrant where cosine is positive. So positive 1/2. 2 pi is 1. And you can put them as pairs. And it'll look like this. So this is the graph. Y equals cosine x. X is between 0 and 2 pi. Can it be 0? Yes. Can it be 2 pi? Yes. Again, I'm reminding you, you have all these PowerPoints. You don't have to write anything except solution to the examples. So again, we can cut it into 4 pieces. This is one piece. One arc is here from 0 to pi over 2. One arc from pi over 2 to pi. One arc from pi to 3 pi over 2, and the blue one is from 3 pi over 2 to 2 pi. So that helps with the graph if you cut it into 4 sub-intervals in essence. So graph is a sinusoidal, just like a sine function using key points or 4 arcs. We can see the points 0, 1, pi over 2, 0, pi, negative 1, 3 pi over 2, 0, 2 pi 1, and that's the graph. And of course, this is one complete cycle. We can continue indefinitely to the right and to the left because it's periodic. Okay. The cosine function this is cosine function, everybody. Y equals cosine x. Is a fundamental trigonometric function with several important properties. Periodicity. The cosine function, this is cosine function, is a periodic function with a period of 2 pi. That means cosine of pi x plus 2 pi is cosine of x for all x. Amplitude, domain, and range, the amplitude of the cosine function is 1. This means that the maximum of cosine x is 1 and the minimum is negative 1. Hence, the range would be from -1 to 1. Its domain is all real numbers. Again, pretty straightforward, very similar to sine function in that sense. Symmetry, even function. The cosine function is an even function. This means cosine of minus x is cosine of x. Its graph is symmetric about the y-axis. Key points, x-intercepts. The cosine function crosses the x-axis at odd multiples of pi over 2. At pi over 2, 3 pi over 2. That means 2n plus 1 times pi over 2. 2n plus 1 represents an odd number where n is an integer. The function reaches its maximum value of 1 at x equals 2n pi, such as 2 pi, for example, in general, and its minimum at pi plus 2n pi. This is the minimum value. So it's pretty straightforward, everybody. And all you have to do, just look at the graph. You can see that. A waveform, the graph of the cosine function is a smooth continuous wave that oscillates between its maximum and minimum values, creating a sinusoidal waveform, just like sine in essence. I hope you can see that if I move this to the right by pi over 2, it becomes a sine. Relation to the unit circle, the cosine function can be defined as the x coordinate of a point on the unit circle, x squared plus y squared equals 1. So sine is the y and cosine is the x coordinate. And again, these properties make the cosine function essential in various fields such as physics, engineering, and signal processing, just as it does the sine function. So y equals cosine x, the period is 2 pi, amplitude is 1. Y equals a cosine omega x, period is 2 pi divided by omega, amplitude is this value in an absolute value sense. And domain, the same as sine, all real numbers from negative to positive. All right, we want to graph this. There are several methods. Let's start with the transformation. And so y equals 3 sine x by transformation. We start with the basic function y equals sine x. And we know y equals sine x has a period of 2 pi, amplitude of 1. And y equals a times sine omega x. Okay, the period is 2 pi over omega, amplitude is absolute value of a. So here's the basic sine function. Now, when we compare, we see that sine has been multiplied by 3. So multiply by 3, there is a vertical stretch, and basically the y coordinate gets multiplied by 3. So this is 0, 0. This becomes pi over 2, 3. This becomes 3 pi over 2, negative 3. This becomes 5 pi over 2, 3, and so forth. So this remains the same. Pi over 2, this becomes 3. This remains the same. 3 pi over 2, negative 3, and it continues indefinitely. So the effect is the domain doesn't change. The domain is still all real numbers. However, the range, it was from -1 to 1. Now it goes from -3 to 3. So it has an effect on the range, everybody. y equals negative sine 2x. We want to do this by transformation. And we know that when y is sine x, period is 2 pi, amplitude is 1. When y is a sine omega x, period is t equals 2 pi over omega, and amplitude is absolute value of a. So first, we have the good old sine, the basic sign that we have seen. Now, the effect of this negative that when we multiply it by -1, it reflects it about the x-axis. It flips it over with respect to the x-axis. So the period is still the same thing, 2 pi. Now we are going to replace the x with 2x. That has an effect on the period, 2 pi over omega, which is 2. So replace x by 2x. There is a horizontal compression by a factor of 1/2. So what happens is that every x coordinate gets divided by 2. Period is 2 pi. Here's what happens. T is 2 pi over omega. 2 pi over 2, because omega is 2, equals pi. Domain remains as before, all real numbers, and range stays the same, -1 to 1. We are not changing the domain or range. And by the way, the amplitude is the absolute value of -1, which is the same thing. But what changes is the period. We want to look at y equals 2 cosine 3x. So we remind everybody when y is cosine x, period is 2 pi, amplitude is 1. If it's a cosine omega x, it changes the t, the period, to 2 pi over omega. Amplitude is the absolute value of a. So first, here's the basic cosine function everybody knows. We're going to multiply it by 2, which means it's going to have a vertical stretch of 2. It's going to have a y coordinates that double up. So for example, here is 0, 1. Now this is pi -1. It's pi -2, and the rest. So that's the effect of number 2. That's the effect of the amplitude. The amplitude is 2. Now we want to replace the x by 3x. That means compression along the x-axis by 3, because t is 2 pi divided by omega. Omega is 3. So just before I show you, this one doesn't change, but this one now, we are dividing it by omega pi divided by 3, comma -2, as an example. 2 pi divided by 3, comma +2. So replace x by 3x. There's a horizontal compression by a factor of 1/3. So this point remains unchanged. This point, you have to divide the x coordinate by 3, because t is 2 pi over omega, or 2 pi over 3. Domain remains all real numbers. Because of this number 2, that we had a vertical stretch, because of this number 2, the range changes from -1 to 1, from -1 to 1 changes to -2 to 2. So it doubles up. So it has an effect on that. So a quick recap. First, the effect of a 2 is that it stretches along the y-axis. So every x coordinate remains unchanged, every y coordinate gets doubled up. And the effect of 3x is that the period shrinks by a factor of 3, becomes 2 power 3. And so every coordinates here, for the x coordinates, we divide by 3, we keep the same y coordinates. Now, it's important to know the relationship between sine and cosine. Ultimately, they are almost the same graph. Sine is cosine of x minus pi over 2. So if you graph cosine of x, the red one, x minus pi over 2, that means you shift it to the right by pi over 2. So look at the red one. If I shift it to the right by pi over 2, this point, now it moves to this point. So it becomes a sine function. And so y equals sine x. If you use a graphing calculator and say y sub 1 is sine x and y sub t is cosine of x minus pi over 2, you see only what? How many graphs? You see only one graph, and even a graphing calculator shows that they are the same. Determine the amplitude and period of a sinusoidal function. So again, reminding everybody, y equals sine x, the period is 2 pi, amplitude is 1. Y equals a sine omega x, period is 2 pi over omega, amplitude is absolute value of a. And so we want to see what's going on with this guy. Okay, that's a general formula that we have. Example 4, y equals -4 cosine of 3x. Amplitude is the absolute value of -4 or 4. So that's pretty straightforward. Period is t equals 2 pi over omega. Omega is 3. So 2 pi over 3. Maybe what helps if we write the following, write down a cosine omega x, so we can see what's going on. So 2 pi over 3. Y equals 3 sine 4x. Let's do the same thing here. A sine omega x. The amplitude is absolute value of 3, which makes it 3. is 2 pi over omega, which is 4, and it makes it pi over 2. And again, the whole thing is here. The synopsis of what we need to know about sinusoidal functions. All right, let's look at the summary of steps for graphing a sinusoidal function of the form y equals a sine omega x, or y equals a cosine omega x, using key points. This method is pretty straightforward, and it should be pretty easy for everybody to follow. Step 1. Determine the amplitude A and period t equals 2 pi over omega. So figure those two values first. When t is 2 pi over omega, divide this interval into 4 subintervals of the same length. Use the endpoints of these subintervals to obtain the 5 key points on the graph. The idea behind the 5 key points is to give you 4 arcs. Plot the 5 key points to obtain the graph of one cycle. Extend on each side to make it complete. You have the key points, you connect them, and then you can complete it. Let's look at this example, y equals 4 cosine 2x. So instead of transformation, we're going to use this easy method that we just discussed. Y equals 4 cosine 2x. Obviously, the amplitude is absolute value of 4, which makes it 4. Now the period is 2 pi over omega. So let me actually write this underneath. So this is a cosine omega x. So that makes it easy to see what's going on, everybody. Two pi divided by omega, which is 2, gives us pi. Now we want to cut this into 4 equal subintervals. What this means is that if you want one cycle of cosine looking like that, it's going to go from 0 to pi. You want 4 arcs, let's cut them into 4 parts. We're going to cut them into 4 parts. So divide this by 4 and you get pi over 4, which means from 0 to pi, it means 0 to pi over 4, pi over 4 to pi over 2, pi over 2 to 3 pi over 4, 3 pi over 4 to pi. So first, pay attention to the first one, everybody, just the first one, 0 to pi over 4. And then keep on adding this number. So this would be the beginning for the next subinterval. Add pi over 4, you get pi over 2. This would be the beginning of the next subinterval. Add pi over 4, you get 3 pi over 4. So this would be the beginning of the next subinterval. This is the last one. Now, let's plug into the original function. X equals 0. If I put 0 here, cosine of 0 gives me 1. That amplitude of 4 makes it 4. So if I plug in 0, I get 0, 4. If I put pi over 4, let me just show you a couple of it. If I put pi over 4, y equals 4 cosine of 2 times pi over 4, which is 4 cosine of pi over 2, and you should know this is 0. So the answer is 0. So if I put pi over 4, I get 0. Let me try pi over 2. Y equals 4 cosine of 2 times pi over 2, which means 4 cosine of pi. You know this is -1. So times 4 is -4. So pi over 2, -4. If you plug in 3 pi over 4, you get 6 pi over 4 or 3 pi over 10 becomes 0. If you plug in pi, 2 times a pi, the cosine is 1 times 4 is 4. So you should recognize easily those 4 pairs. So I'm going to erase this. So you plot 1, 2, 3, 4, 5 points. 1, 2, 3, 4, 5 points. Now connect them. That's the graph of one complete cycle. Now go indefinitely on the left and right, and that's the graph that you are looking for. So very straightforward, everybody. I hope everybody's fine with that. So we can easily move on. So again, in short, cut the period into 2 equal parts and the 5 key points, and you will easily get to the answer by plotting those pairs. Those are really easy. Okay, let's continue with that thoughts. Let's see what we need to do here. And again, we are dealing with cosine, and let's write a cosine omega x. So the amplitude is absolute value of -3 or +3. T is 2 pi over omega. That means 2 pi over pi over 4, which means 8. 2 pi divided by pi over 4 is 8. So you have to go from 0 to 8, and you're going to cut it into 4 equal parts. So we are going to divide 8 by 4, resulting in 2. So we are going to go from 0 to 2, 2 to 4, 4 to 6, 6 to 8. Those are the 4 sub-intervals. Let me just write this, 4 sub-intervals. All right, let's plug in. If I plug in here, I get cosine of 0, which is positive 1 times negative 3 is negative 3. So 0 gives me negative 3. If I put 0, I get negative 3. If I put 2, let me just show you, for example. If I put 2 minus 3 cosine of pi over 4 times 2, that means minus 3 cosine of 2 pi over 4 or pi over 2. You know this is 0. So that gives me negative 3 times 0 or 0. So again, 0 comma negative 3 and then 2 comma 0. Let's do one more. Let's plug in 4 here. So if I put 4, I get negative 3 cosine of power 4 times 4, which means minus 3 cosine of pi. Okay. And what is cosine of pi? Negative 1 times negative 3 is positive 3. And so I get 4 positive 3. Okay. If I put 6 pi over 4 is 3 pi over 2, this is 0 times negative 3 is 0. If I put 8 pi divided by 4 is 2, and 2 pi cosine is positive 1 times negative 3 comes negative 3. So 8 comma negative 3. I hope you can see how easily we can come up with the answer. Let's plot those pairs. So the pairs are 0, negative 3, at 2, 0, 4, 3, 6, 0, 8 minus 3. So connect them like with a smooth curve. Go indefinitely on the left and right. This is a complete cycle. And that's the graph of it. All right, we're going to look at this example, everybody. And again, let me write y equals a sine omega x. So we know what's going on. So the amplitude is the absolute value of 5, which makes it 5. And the period is 2 pi over omega. That means 2 pi over 3. So that's pretty straightforward, everybody. And all we have to do, cut 0 to 2 pi over 3 into 4 equal parts. So we divide this number by 4, and we get 2 pi over 12 or pi over 6. That means we're going to go from 0 to pi over 6, then from pi over 6 to add pi over 6, pi over 3, and the rest of them. So I hope you see that. This means 0 to pi over 6. Now this is the beginning of the next one. Add pi over 6 to this, you get pi over 3. This is the beginning of the next one. Add pi over 6, you get pi over 2, and all the way to the end. So Along the x-axis, you put 0, power 6, power 3, power 2, 2 power 3. You have to put those. Now let's plug in. Let's start with 0. 0 is easy. Sine of 0 is 0, so that gives you 5 times 0 is 0. But what happens if you put pi over 6? So let me just quickly show you a couple of them. If I put pi over 6, I get 5 sine of 3 times pi over 6, which is 5 sine of 3 pi over 6 means pi over 2. Sine of pi over 2 is 1. So I get 5, which means pi over 6 has a y coordinate 5. That's the minimum. Let's do one more. Let's do pi over 3. 5 sine of pi over 3 times 3, right? Times 3. That means 5 sine of pi, and sine of pi is 0, so it's 0. So that means at pi over 3, we get 0. And keep on doing the same thing. Plug in the rest of it. Let's do pi over 2 also. If I put pi over 2 in there, let me use a different color. Let's say we put pi over 2 here. So 5 sine of 3 times pi over 2. And sine of 3 pi over 2 is negative 1, so it's minus 5, which means pi over 2 negative 5. That's it. So you can find them by plugging in. It's easy class, so I'm going to erase it. So plot those pairs. 0, 0, power 6, 5, power 3, 0, power 2 minus 5, and you can easily see that. So plot those again. We are going to go from 0 to 2 power 3. 0 to 2 power 3. Okay, so this is 2 power 3, everybody. And then plot those and connect them with a smooth curve. So again, please understand this is 2 pi over 3, okay? So 0 to 2 pi over 3 has been cut into 4 equal parts. So plot those points, make a nice and smooth curve. Now we continue indefinitely on both sides to make it periodic. This is a complete cycle, and this continues indefinitely on both sides. Okay. What about y equals 2 sine minus pi over 2 over x? Whenever you have a negative argument, you really want to get rid of the negative and make it positive by using the fact that sinusoidal functions, all trigonometric functions, some are odd, some are even. Sine is an odd function. So this negative can come out, right? Because sine of minus x is minus sine x. And because we should know sine minus x and minus, that's how you graph it. It's a lot easier that. So obviously this gives you the amplitude. Absolute value is positive 2. And you divide by this one to get the omega. 2 pi divided by omega. 2 pi divided by pi over 2 gives you 4. Again, pretty straightforward, everybody. I hope everybody's fine with that. And we are going to cut this into 4 equal parts becomes 1, meaning we're going to go from 0 to 1, 1 to 2, 2 to 3, 3 to 4. That's the 4 sub-intervals. So we cut this into 4, becomes 1, 0 to 1, 1 to 2, and so forth. So that means now, plug in the endpoints into this, either this one or this one, makes no difference now. You want to evaluate it either way is fine. It can be easily evaluated. So if we go with this one, if you plug in 0, sine of 0 is 0, so you get 0, 0. So 0 will give you 0. But let's say 1, for example. So 0 is easy to see. If I put 1 in here, I get minus 2 sine of power 2 times 1, which is sine of power 2 1, so we get negative 2. That means we have the pair 1 comma negative 2. Let's plug in 2. Minus 2 sine of power 2 times 2. This is pi, sine of pi is 0. So we get 2, 0. If I plug in 3, 3 power 2, the sign is negative 1 times minus 2 becomes positive 1. Let me show you that one. I want to make sure. So if I put 3 minus 2 sine of power 2 times 3, this is sine of 3 power 2. Negative 1 times negative 2 is positive 2. Therefore, the pair 3 comma 2. And if I put the 4 here, 4 divided by 2 gives you 2. 2 pi, sine of 2 pi is 0. So you should be able to see these pairs. And I'm going to erase the mess so we can plot these pairs. So we plot 0, 0, 1, negative 2, 2, 0, 3, 2, 4, 0. And that's the graph, a smooth curve. We go indefinitely on both sides, and that's the answer. Sometimes they say just, draw a complete cycle, and that's good enough. Sometimes they want more than that, okay? All right. In order to graph this, you can ignore the negative 2 and graph this one. Because the effect of this that goes up and down along the y-axis, in this case, it goes down by 2 units. So for now, just work on this, okay? Which means the amplitude is absolute value of negative 4 over 4. T is 2 pi over omega, and omega is the coefficient of x. 2 pi divided by pi makes it 2. You got to cut the 2 into 4 equal parts. 2 divided by 4 becomes 1/2. So we're going to go from 0 to 1/2, 1/2 to 1, 1 to 3/2, 3/2 to 2. That's the idea. Okay. So again, I think it's pretty straightforward, everybody. Now, let's plug it into this. If I put 0, cosine of 0 is 1 times negative 4 is negative 4. So please understand 0 gives you negative 4. Let me just do a couple of them. So 0 cosine of 0 is 1, gives you negative 4. So 0 gives us negative 4. Let's plug in 1/2. So minus 4 cosine of negative pi over 2, right? Pi times negative 1/2. So negative pi over 2 and pi over 2 makes no difference. Cosine is 0. So that gives you 0. That means 1/2, comma 0. Let's plug in 1. If I put 1, I get minus 4 cosine of pi times 1, or pi. You know cosine of pi is negative 1, so you get positive 4. So 1, positive. So we can see that. We're going to graph it. It's very easy. You can figure out the rest of them as well. So these are the pairs, and I showed the work for this one, and this one. If you put 3/2, please understand 3/2 means 3/2 pi, which cosine is 0. If you put 2 pi, the cosine is positive 1 times negative 4 makes it negative 4. So plot those pairs as 0, negative 4, 1/2, 0, 1, 4, 3/2, 0, 2, negative 4, and that's the graph. It's a smooth graph. And now you're going to go indefinitely on both sides to make it a, this is one cycle. This is the cosine function, y equals minus 4 cosine pi x. So far we've done this, but this is what we want. This is what we want. And the effect of it is shift it down, same thing, bring it down by 2 units. So subtract, so shift down by 2 units. Subtract vertical shift down by 2 units. So this one comes down by 2 units. So for example, this point, 0, negative 4 class becomes 0, negative 6. Okay. 1/2 0 becomes 1/2 negative 2. 1 4 becomes 1 2. 3/2 0, 3/2 negative 2. 2 negative 4, 2 negative 6. So bring it down by how many units? By 2 units. Finding an equation of a sinusoidal graph, we want to find an equation for the graph shown. All right, let's see what is this point 0, 3. What is this point 1 4 0? What is this point 1/2 negative 3? What is this point 1 3? Okay, so let's plot this point and this point and this point. Just this gives you that must be a cosine function. So a cosine omega x, this looks like a cosine. Cosine has the y-intercept of 0, 1. If it's 0, 3, that means a must be 3. So amplitude is 3 because of this. So we found a. We know t is 2 pi over omega, and t stops here. T is 1 here. So t, this is 1 period, okay? T, which is 2 pi over omega, is 1. So omega must be 2 pi if you do the cross product. Omega must be 2 pi. Plug in. We have the a, we have the omega, and the answer is y equals 3 cosine 2 pi x. So definitely it looks like a cosine function, and this is the case. And by the way, when you find the answer, check. All you have to check with those pairs that are known, like this one, this one, this one. Any of those pairs that are known, double check. Plug in. For example, if you plug in 0, do you get 3? If you plug in 1/2, do you get negative 3, and so on. You find the answer and you check. Let's look at this function. We continue finding an equation of the graph, and it's important to put important points. 0, 0. 1, negative 2. 2, 0. 3, 2. 4, 0. So those are the pairs. 0, 0, 2, 0, 4, 0. We also have those pairs. It's been mixed up, class. This is 3, 2. 1, negative. So we have those pairs. This gives you a complete cycle. So the period is 4, the amplitude. Notice for sinusoidal functions, the max is 1, the mean is negative 1, but in this case, the max is 2. This is 2, and this is negative 2. So that means the amplitude is 2. So this one has 1, negative 2 coordinates. This one has 3, 2. Therefore, just make sure it's this way. This is 3, 2, 1, negative 2. So the amplitude is 2. However, A is negative 2 because everybody knows that the sine function is like that, but it's flipped over with respect to the x-axis. So note that this is a reflection over the x-axis of the sine function, and therefore A is negative 2. What about t? T is a 4. So t is 2 pi over omega, and it's equal to 4. Cross product. That means 4 omega is 2 pi. Omega is 2 pi over 4, or pi over 2. And therefore, the formula becomes y equals sine omega x equals negative 2 sine of pi over 2 x. And that's the final answer, everybody.